just going to go over the mole concept. On the top right is the template that you guys are going to follow. Okay, so you always set up your T-chart the exact same way. Whatever number's in the problem, you write on the top left. On the top right is what you're looking for, and these units are always going to match. This number here, this number is going to change sometimes. Okay, that's up to you to figure out what's there. If it's in grams, you look at the periodic table. If it's in atoms, formula units, molecules, you're going to use Avogadro's number. So let's just get to it, and you can check your answers with mine. So it says you have a tablet that has 500 atoms. So the 500 is the only number that was given to me. So it goes in the top left-hand corner. Okay, it says atoms, so I know that if this is atoms, this is going to be atoms. The number that goes in front of atoms is Avogadro's number, and I wrote that right there. When I divided it, you should get this. If you are not getting that, then it's probably a calculator error. Anybody have any questions on that one? It says 8.3 times 10 to the negative 22. This is number 47. 8.3. You can go ahead and do number 48 by yourself. Number 49, I just show you how to set it up. You have one number in the problem. That one number goes on the top left. Because this is grams of MgCl, this will be grams of MgCl. Okay, they're going to match no matter what. Even if you don't know what numbers are going to go in there, you can at least set it up. It says how many formula units. So what you're looking for goes over here. Avogadro number goes in that place. Okay, use Avogadro's number for formula units, atoms, molecules, anything that's not moles or grams. Where are you going to find grams of MgCl? You need to look up on periodic table. I set the next one up for you, so you'll see a pattern. There's only one number in this whole problem. 3.01 times 10 to the 23 moles. If this is moles, I know that this is moles. What number do you always put in front of moles? 1. And for molecules, use Avogadro's number. Again, you'll use Avogadro's number for anything that is not moles or grams. So you'll use it for molecules, atoms, formula units. I feel like there's another one I'm missing. So if it's not moles and if it's not grams, use Avogadro's number. Number 51, there's one number in that problem. Okay, so these match. It's F and a U for formula units of NaCl. What number goes in front of formula units? You have to think about that. What do we want? Atoms. I'm going to flip the page. We're going to skip the stoichiometry section right now. You need to have your T-charts out for the stoichiometry section. The grams to moles, moles to grams, gram to gram, mole to mole. I'm not going to do it with you right now, no, because I don't have my T-charts in front of me. So I'll start with solutions. Well, I can actually start. Number 52, in the reaction, sorry, N N2 plus 3H2 is 2NH3. Okay, so what is the mole ratio of nitrogen to ammonia? Nitrogen to ammonia. So you look for nitrogen. Good job, Jonah. And, oh, I'm sorry. Nitrogen to ammonia. Well, what's the coefficient for nitrogen? The coefficient. 1. We have 1 nitrogen. And the coefficient of ammonia? Here's your ratio. That's it. Okay, don't use the subscripts. I know sometimes you want to use that, but it's based off coefficients. The coefficients is a ratio. So let's go ahead and do number 53. And the ratio, and they give it to you here. What is the mole ratio of aluminum to oxygen? So what's the big number in front of aluminum only?
2.
No, aluminum only.
4.
Yeah. Okay, and oxygen?
3.
Yep.
43.
That's the answer.
That's
Mm-hmm. So I'm going to, we can go ahead and skip down to 57. Yes.
How is it 4 again for
There's,
start on the other side?
you can start anywhere. They're just asking you for a ratio. They could have said oxygen to aluminum oxide.
No, because the aluminum in the middle is by itself.
Okay, thank you. So for percent yield, do you guys remember the formula? We're going to skip to 57. It's actual and theoretical. Which one goes on top? Okay, so let's just plug in what we have. It says there is a reaction. 100 grams was made. So that's literally what was made. That was what was actually made. But in theory, 185 should have been made. Okay, you just plug that in your calculator and you'll get the answer. Let's go to the right side. Solutions. Which of the following be soluble in water? So you have to turn your periodic table to the solubility chart. This is the solubility chart. It says soluble. There's a list of things that are soluble. That means they will dissolve. And then the second list is insoluble. They will not dissolve unless it's paired with some of these exceptions. So you have to go one by one, H, G, and I. Okay, so look on the table. I see I. It's right here. It's in the soluble list unless it is paired with Hg. Is it paired with Hg for A? Yes. So it's no longer soluble. If it is paired with something in the exception list, it does the opposite. So this is insoluble. I'm just going to put an I so it can stay organized. So I'll look up KCl. I see Cl's right here. Soluble. Unless it's with Ag, Pb, Hg, which it is not. It's with K. So yes, this is soluble. So which of the following soluble? B. 59. Which of the following would not be soluble? So I'm just going to start at the top. Hold on. Which of the following combinations would not be soluble in water? Okay, well, CN is soluble no matter what. And you probably won't have a question that looks like this. We don't usually. Here's CN. It says it's soluble no matter what. There's no exceptions. So this one, oh, it wants to know if every single one is soluble no matter what. OH is insoluble. I has some exceptions, so it's not that. ClO. So I go to ClO, it's right here. It's soluble no matter what. So anything that's here, if there's, if there's 3 elements out of your options, A, B, C, D, that are in this category, that's gonna be the answer because those are always soluble no matter what. There's no exceptions. So you're gonna look out of your options, which 3 fall in this area. So you guys can go ahead and do that. Number 61. I'm just gonna make a note here if you wanted to draw it on your cheat sheet that solids generally go up like that. This is a solids pattern. And gases decrease. And then something else that's going to be helpful, if it's above the line, super saturated, on the line, saturated, under the line.
Gases decrease?
Yeah, as temperature increases, gases decrease. Because remember that bottom axis is temperature. So after you get those down, I'm looking at number 61. It says 20 grams at 50 degrees for KClO3. So I'm going to look for KClO3. My 20 grams and 50 degrees, it put me right on the dot. Yep. So I'll let you guys work through those. Number 63, I can see it switches units to dilution. So what is the concentration? So it wants molarity. It has this many moles and this many liters. So you guys want the molarity triangle. And that's something I would also include. Include that on your cheat sheet. The moles is on top. And then liters and molarities on the bottom. And again, the way you use this triangle, whatever you don't have, you put your finger over. So if I'm looking for moles, I just multiply molarity and liters. If I'm looking for liters, I divide moles and molarity. So I'm looking for molarity because it says what is the concentration. So 1.75 is on top, divided by 12. That's gonna give me my molarity. So you can work that out. Number 64, a lot of students always get this wrong. Which of the following solutions has the greatest concentration? So the biggest number, okay, equals strongest. So you're looking for M. Because that's concentration. So in each one, they give you moles and liters. So you're just dividing moles divided by liters will give you the concentration. You're going to find the concentration of A, B, and C, and D. Pick the biggest number. Okay, so for A, it's 0.75 divided by 0.5. For B,